So we'll be starting with the Banwas. The Banwas should incorporate the following operational modes. Automatic brought into operation when the ship's heading or track control system is activated, inhibited when the system is not activated. Manual on in operation constantly. Manual off does not operate under any circumstances. Describe the sequence of indications and alarms on Banwas. Once operational, the alarm switch should remain dormant for a period of 3 to 12 minutes decided by the captain. At the end of this dormant period, the alarm should initiate a visual indication on bridge. If not reset, the Banwa should additionally sound a first stage audible alarm on the bridge for 15 seconds. After the visual indication is initiated, if not reset, the Banwa should additionally sound a second stage remote audible alarm in the backup officers and or master's location for 15 seconds. After the first stage audible alarm is initiated, if not reset, the Banwa should additionally sound the third stage remote audible alarms at the location of further crew members capable of taking corrective actions. 90 seconds after the second stage remote audible alarm is initiated. Now what is AIS should transmit information at a rate sufficient to ensure timely updates and accurate tracking of vessels. The system should support various messages type including static informations and dynamic informations. AI should provide accurate and reliable data especially regarding the vessel's positions, course and speed. AIS equipment should be designed to ensure interoperability, allowing vessels to exchange information seamlessly. As data should be integrated into navigation and collisions avoidance system on vessels to enhance situational awareness and safety. AIS use a reliable data link for communication between vessels and shore-based stations. What information is transmitted by automatic AIS? IMO number, call sign, name, length, beam, type of ships, location, position of fixing. यार yes, okay. Dynamic is the ship's position, accuracy, indication, integrate status, timing, UTC, heading, and okay. Then voice related data, ship start, hazardous cargo, destination, ETA, and operation. What is the time period of each data provided by ship at anchor? Reporting interval 3 minutes. Ship speed 40 knots, 12 seconds. ये याद नहीं करने की ज़रूरत है. Voice related information every 6 minutes with data has been amended on a request. AIS operates on which frequency and range? AIS-1 works on frequency 161.975 MHz channel 87B simplex for ship to ship. This is very important. 161.975 MHz channel 87B simplex for ship to ship. AIS-2 162.025 MHz channel 88B duplex for ships to shore. AIS receiving stations fitted with an external antenna placed 15 meters over sea level can get information from all the AIS equipped ships that sail with 15 to 20 nautical mile radius of its locations. Explain the working of AIS. So AIS is a maritime communication system that allows vessels to broadcast and receive information about their identity, position, course, speed, and other relevant details. AIS enhances maritime safety by improving situational awareness, aiding navigations, and facilitating avoidance of collisions. Ships are equipped with AIS transporter that continuously broadcast information about the vessels. The AIS transporter on a vessel's broadcast information at regular intervals. The information includes the vessel's maritime mobile service identifier, COG, speed, heading, and other relevant details. AIS uses very high frequency radio frequencies, especially on channels 87B and 88B. AIS uses a time sharing technique known as TDMA, allowing multiple vessels to share the same frequency without interference. The TDMA slots enable vessels to transmit their information in assigned time intervals. Shore-based AIS receiving station. Other vessels equipped with AIS receive pick up the transmitted AIS data. Vessels equipped with AIS receiver displays and receives the information navigation system on dedicated AIS displays. Time division multiple access is a communication technique where multiple users share the same frequency channel by dividing time into slots. Each user is assigned a special time slot during which they can transmit their data. In the case of AIS, this is used to manage communication on VHF radio frequency allocated for AIS. Self-organizing time division multiple access. The term self-organizing Self-organizing indicate that a system dynamically adapts to communicate needs to for different users without requiring central coordination. In context of AIs, this means that vessel using CRTDMA can autonomously adjust their time slot for data transmission based on the prevailing communication condition. Why AI is not to be used for collision avoidance? The accuracy of AI's information received is only as good as the accuracy of the AI's information transmitted. The position received on AI's display must not be referenced to the WGS 84 datum. User must be aware that the AIs might transmit anonymous information from another ships, or not all ships are fitted with AIs. Vessel types: Class A AIs is typically used by larger vessels including commercial ships, passenger vessels and vessels with gross tonnage greater than 300 tons. It is mandated for SOLAS compliance. Class B AIs primarily designed for smaller vessels including recreational boats, fishing vessels and non-SOLAS compliant ships. Transmission power: Class A operates at a higher transmission unit 12.5 and B2. Class A reporting intervals requires more frequent position reports transmitting every 2 seconds, with vessels are navigating speed and every 3 minutes. Position report transmitting every 2 seconds when vessels are navigating at high speed, and every 3 minutes when stationary or at anchor. And every 3 minutes when at anchor, and 3 minutes when it's stationary or at anchor. Okay, it provides more detailed frequent information for collision avoidance. Class B AIs generally has longer reporting intervals, it transmitting every 30 seconds when vessels are moving at every 6 minutes and stationary or at anchor. 6 minutes or stationary or at anchor. Okay, very less frequent than Class A. Data capacity has a higher capacity. AI provides essentials such as vessel's name, position, course, speed, but has a lower data capacity of Class A. Now, what is Doppler log? Doppler log is based on the principle of Doppler shift in frequency method. Different change in frequency received when distance between source and observer is changing due to the motions of the either source or the observer or both. In Doppler log, an observer is moving with the source of sounds or reflecting plane, then the received frequency. By observing the receiving frequency is known as the volume of transmitted frequency and velocity of sound. In sea water, the speed of the vessels can be determined. Principle of the Doppler log. A transmitter is fitted on the ship's keel with a transmitter beam acoustic at an angle usually 60 degrees to the keel in the forward direction. This gives the component V cos alpha of the ship's velocity toward the seabed, thus causing the Doppler shift and the received frequency. What is the angle transmitted by the of the acoustic wave with respect to the keel should always be 60. The transducer should make a perfect angle of 60 degree with respect to the keel, or else the speed indicated will be inaccurate. The frequency generated by the oscillator must be accurate and constant. Any deviation in the frequency will result in the speed indicated being an error. In practice, the ship has the vertical motions and the Doppler shift measurement will have a component of these vertical motions. This problem is overcome by installing two transducers, one transmitting in the forward direction, another in the aft direction, the same angle. This arrangement is known as Janus configuration, where if the frequency is received by the forward transducer, while the aft transducer will have the component V cos alpha with negative sign, since the transducer is moving away from the reflecting surface, the seabed. By measuring the difference between the two Doppler shift frequency, the vertical component will cancel out while the horizontal will add. Frequency: by measuring the difference between two Doppler shift frequency, the vertical component will cancel out while the horizontal will add. What are the errors of Doppler log? Errors in transducer orientations that may perfect angle of 60 with respect to the keel, or else the speed indicated will be inaccurate. Error in oscillator frequency: the frequency generated by the oscillator must be accurate and constant. Any deviation in the frequency will result in this indicated error. Error in propagation velocity of the velocity of the gas at temperature 16 degree and 3.4% is salinity and 1505 second, but generally it takes 500 for the calculation of latest changes and temperature salinity. To compensate that due to the temperature variation, thermometer is mounted near the transducer and change in velocity of acoustic wave therefore away from the standard value due to the change in seawater temperature is accounted for. Error due to the ship's motion: due to the interval between the transmission and reception, the ships may marginally roll or pitch, and thereby the angle of transmission and reception can change, and for the 2 degree difference between the angle of transmission and reception, the net effect will be error of 0.1% of the indicator, which is marginal and can be neglected. Error due to the effect on rolling and pitching will cause an error in the forward speed. It has no effect on the afterward shift. Similarly, rolling will cause an error in the adverse speed and not in the forward. Actual speed is equal to indicated speed divided by cos beta, where cos beta is the angle of the pitching for forward speed and angle of rolling in case of backward speed. So actual speed is equals to 15 by cos 10 degree equal 15.23. Error due to the inaccuracy measure of comparison frequency. The difference in the frequency received by the forward and after transmitter must be accurate and okay. Magnetic compass. Now how to obtain compass error. Following transit bearing, like it's transit bearing and when two charted objects are in transit, compass bearing is taken and the true bearing is taken from chart using a ruler compass of the compass bearing and the true bearing gives the compass error. Example, true bearing 45, compass bearing 048. So the compass error is 3 degree west. Compass error, compass west error, नहीं compass best error west. Compass bearing 48, so error is west 3 degree. वेरिएशन 11 डिग्री का ईस्ट का है तो डेविएशन कितना हो गया 8 डिग्री ईस्ट का डेविएशन हो गया. कैसे, दोनों अपोजिट है, माइनस कर दिया. बाय बियरिंग फ्रॉम अ नोन पोजीशन सेगमेंट. ठीक है यार. कंपास एरर बाय जेटी. ओके. एम्पलीट्यूड मेथड, एजीमुथ कैलकुलेशंस. ओके. हाउ टू रिमूव बबल from a magnetic compass. A bubble in the wall is the rare occurrence which must be remedied by the following instruction. Tilt the ball until the filter hole comes uppermost. The hole is provided on the side of the ball. Unscrew the stud screw, provide top up with ethyl alcohol. It is not available. Distilled water would be added. Screw the stud screw back into the place. Gently let the ball return to the upright. Now permanent characters. Permanent character. In the center of the lower half of the binnacle there are a number of horizontal holes. In the center of the lower half of the binnacle, there is a number of horizontal both forward and aft, especially for hard iron or permanent character magnet, which are meant to offset the undesirable disturbing magnetic effect caused by the ship's steel hull. The number of connectors is designed by the qualified compass adjuster. Heading error characters, healing error character. The 2/3 end binnacle, there is a vertical brass tube at the center in which slides a bucket. This bucket has magnets in it called healing error characters. This bucket is held in position by a brass chain. The number and location of each magnet in this bucket and the distance of the bucket from the compass card must be altered except during the compass adjustment by a qualified adjuster. This door giving access to the corrector magnet should always remain locked and opened only during the compass adjustment. Only during the compass adjustment. Quadrantal characters. These are two soft iron spheres which are fitted in the bracket one other of the binnacle. The bracket are also slotted so that the distance between the sphere can be altered as desired during the compass adjustment. Quadrantal characters. These are two soft iron spheres which are fitted in brackets one on either side of the binnacle. The brackets are slotted so that the distance between the spheres can be altered as desired during the compass adjustment. The compass adjustment. Flinders bars. This is a soft iron character, diameter 7.2 to 10 cm, inserted in 10 cm long brass case, fitted vertically on the forward or on the aft part of the binnacle. If the ship has moved superstructure abaft, the flinders bar is fitted in the forward part. Errors of the echosounder. Velocity of propagation in water. Acoustic wave is very okay. This is same as the general stylus speed error. The stylus is rotating with a certain constant speed and the speed of the stylus is such that the time taken for stylus to travel from top of it is exactly equal to the rate of acoustic pulse to travel twice the distance of the range selected. Due to the fluctuation in supply voltage, the speed of the stylus motor changes and the depth recorded will be inaccurate. Okay, multiple echoes. The echo may be reflected by a number of times between the keel and the seabed, thereby giving a multiple depth marks on the record. In such a case, the first echo is the correct depth. Pythagoras error. This error is found when two transducers are used, one for transmission, other for reception. This error can be determined by the formula equals to d minus underscore d square minus x square by 4. Pythagoras error. The error is found when two transducers is used, one for transmission, other for the reception. The error can be determined by the formula where d is the recorded depth, x is the spacing between. Okay, the error. Thermal and density, where d is the depth, recorded depth, x is the spacing between two transducers. Okay. Okay. This error is more dangerous in shallow depth and is negligible when water is used because the same transfer is used for transmission and reception of positive. Thermal and density layer. The density of the water varies with the temperature and salinity. Okay, aeration is referred to an error or distortion in the measurement caused by the preferences of air bubbles in foam in the water. When the air bubbles foam are present in the water, they can interfere with the transmission and reception sound waves, leading to the inaccurate in-depth readings. To minimize aeration errors, eco sounders user may need to be considered for factors such as the location of the transducer, the depth of the transducer below the waterline, and the overall continuation of the water. How depths can be corrected with error due to the salinity and temperature of water. The change in temperature, the tables for velocity of sound in pure water and sea water. Okay, the change in pressure has a very little effect, whereas changes in the temperature and salinity influences more on the velocity of the acoustic wave. The depth can be corrected to true depth from the tables of the velocity of the sound in pure water and sea water. What happens to echo sounder when the vessel goes from sea water to fresh water? When an echo sounder transition from fresh water to sea water, it encounters changes in the properties of the water, such as salinity, which affect its performance. Sea water is denser and has a higher salinity compared to fresh water. As a result, the speed of sound in sea water is generally higher than in fresh water. The change in sound speed can impact the accuracy of depth measurement made by echo sounder. In general, the echo sounders are designed to perform well in seawater, and their accuracy is often optimized for such conditions. Seawater, being more conductive, can enhance the current transmission of sound waves, which can result in better performance in terms of range and resolution. In coastal areas where there might be breaking waves or turbulence, there could be an increased likelihood of aeration effects, potentially leading to errors in depth measurement. This is due to the presence of bubbles and foams in seawater, affecting the transmission and reception of sound waves. Ranging and in an echo sounder, the rotating stylus is with a certain constant speed, and the transmission takes place with the stylus passes the zero mark. When the stylus can reach is selected, the transmission will still take a place when it comes to zero, but the stylus speed is reduced because the stylus has to remain on the paper for longer period of time. Since the echoes are written from greater, this time is known as the ranging, and the scales are generally provided 0 to 500, 0 to 100. Okay, since the same length of paper now covers a larger depth, the graduation becomes closer and it becomes difficult to read the depth accuracy. Phasing arrangement is used to avoid this. Phasing you can change from 100 to 200 or 50 to 100 like this. The speed study mode is kept constant, but the transmission point is advanced. Four sensors are positioned around a stylus when stylus is rotating, and it consists of a magnetic mounted on the belt generates a pulse when it passes the sensor. When in the term activates the when the minimum range 100 is selected is exactly when the stylus passes 0. The bottom scale of the paper will depend on the speed of the stylus and is set to 100 meter. On selecting higher range like 100 to 200 meter, sensor 2 is used to activate the transmitter, and the 0 of the scale is so shifted that the top of the paper corresponds to the 100 meter. Since the speed of the stylus motor remains same, the bottom graduation corresponds to 200 meter. Similarly, for measuring higher ranges, different sensors are selected, and transmission rim will advance accordingly. The speed of the stylus will remain same as long as each range scale correspond to similar difference of depth, that is 0 to 100 meter, 100 to 200 meters, 200 to 300 meters. What is the global position system? The segment divided into three parts. Ground-based segments. It consists of four land-based, that is Indian Ocean, Diego Suarez, Pacific area, Atlantic area. It also has a master control station and upload stations located at Colorado Springs in USA. The monitoring station tracks the satellite, obtain the data from the satellites, and pass the information to master control station. After receiving the data from monitoring station, the master control station does the necessary computation to predict the future path and the position of all satellites. The master control station also determines the error of the atomic clocks in all these satellites. The updated data are fed to the upload stations, which in turn transmit the same data to each satellite 3 times a day. Space segment. It consists of 24 operational satellites evenly placed in 6 different orbits. All the satellites have a propulsion system to maintain their orbital path, and the angle between each of the 6 orbital planes and equator plane, that is inclination, is 55 degrees. The difference in the right ascension of ascending the nodes of successive orbit is 60 degrees. These satellites are launched at a height of 20 kilometers above the 20,200 kilometers above the Earth's surface. The orbital speed of each satellite is 3.9 kilometers per second, and it takes 12 hours to complete one orbit. Each satellite that passes over the zenith of the other will remain above the horizon for about 5 years approximately, and it has coverage of
4,500 nautical miles approx. The satellites are so launched in the orbit that a receiver placed anywhere on the Earth's surface can receive the signal from minimum 4 satellites with an elevation of more than 9.5 user segment. It consists of a receiving antenna receiver with a built-in computer and display. The receiver locks on to one satellite, and from this satellite it operates the almanac of all other satellites and thereby select the four most suitable satellite for position fixing. The fix obtained is displayed on the displayed unit with other information such as the course and speed made good, etc. Receivers designed to receive only one frequency are known as the single frequency receiver. To enhance the position accuracy, there are dual frequency receiver that can receive both the frequencies. In the interest of continued safe navigation practice, IHO and IMO have jointly established a global navigational warning system which is known as the worldwide warning system. Warning are sent using the methods such as Navtex and Inmarsat. Once the warning is no longer relevant, the notice is cancelled. Longer term hazards are converted into notice to marina. There are three types of warning: nav area warning, coastal nav warnings, and local warnings. Nav area warning is cover the worldwide, which of the form purpose of 21 geographical area, which is covered and listed in the ALS volume 3 and 5. Nav area warning are issued by radio and Inmarsat transmission using EGC safety net. This is normally from 250 nautical mile from the coast out from the to the border of the nav area. Coastal warnings, these are issued from the coast of origin and affect a specific coastal region in the area of hazard. They are transmitted on Navtex, VHF, MF radio installations. Usually this covers the area from far away of waterway marks of a port out of 250 nautical mile. Local warning, this may supplement coastal warning and provide detailed informations which often relates that directly to the inshore water. As such, they may not affect the ocean going vessels to other some extent of vessels working inshore. The warning often originates from a coast guard and port controls and may be transmitted in national languages only. What are the errors of ionospheric troposphere delay? The radio wave radiated by the satellite when passing through the different layers of the ionosphere and troposphere. The velocity of the waves vary, which affects the time differences measurement, and the fix will not be accurate. Use clock error. If the user clock is not perfectly synchronized with the satellite clock, the range's measurement will not be accurate, and the range measurement along with clock error is known as pseudo range. This error can be eliminated with the receiver on board by obtaining the pseudo range from 3 satellites, and is done automatically with the receiver. Satellite clock error. This error is caused due to the error in the satellite clock with respect to GPS time. This is monitored by the ground-based segment, and error in the satellite's clock form part of the 30-second navigational messages. Geometric dilation of resistance. It describes the error caused by the relative position of the GPS satellite. The geometry of the position of the satellite determines the angle of cut, which governs the quality of position obtained. Wider the angular separation between satellite, more accurate is the fix. Is the interaction with the right angles. The lower the GDOP value, higher the accuracy of the fix, and this GDOP value is indicated on the display unit. Multipath error is caused by the satellite signals arriving in the ship's antenna both directly from the satellite and having been reflected by some other object. Thus, the two signals are received simultaneously, which will cause the distortion or signal from the range measurement is obtained. Deviation of satellite from predicted path. The satellites are monitored and their path are predicted by ground-based segment. However, between two consecutive monitoring of the same satellite, there may be minor drift from their predicted paths, resulting in small position accuracy. What is differential global positioning system? The differential global is used to enhance the accuracy of the normal GPS system so that it can be used for survey, drilling, oceanography, where the high accuracy of position fixing is required. The DGPS reference station is situated at a fixed location, and from this position the GPS receiver tracks all the satellites within its sight, obtain the data from them, and compute the correct positions on the position obtained from the GPS and its actual position. These corrections are then broadcast to GPS user to improve their position accuracy. Reference station is the fixed location from the GPS receiver track all the satellites within its sight, the data from them, and compute the correction. What is the difference between a GPS and GPS? Uses the network of satellite in space to provide the locations information on the Earth's GPS receives the signal from the multipath satellite, and they use the information to calculate the precise location in terms of light and long and sometimes altitude. DGPS is an answer to GPS that brings accuracy into the reference station with the known location that receive a signal from the GPS satellites. The reference station calculate the difference between the actual location and the GPS calculated location. The GPS error can be checked by GDOP value more than 4 mean there is a GDOP error. HDOP value more than 4 there is a GDOP error. Verifying GPS position using celestial sites. Verifying position using terrestrial fix. Long range identification and tracking. What is the long range identification tracking? The LRIT system is a designated international organization, maritime organization system designed to collect and disseminate the vessel's positions. Information received from IO member states. The main purpose of LRIT is to enable, this is all bullshit, how it works. The LRIT, there are two aspects of LRIT reporting aspect where vessels to where apply the export their identity and which are date and time and 6 hours. The receiving aspects of coastal can purchase reports. Vessels are within 100 nautical 1000 nautical miles or where port states can purchase the reports when vessel seeks entry into port or at a determined distance or time from that part. Now describe the LRIT systems and its component. The LRIT system consists of the shipborne LRIT information transmitting information, the communication service provider, application service provider, LRIT data, and okay, yes, we have to learn the process and we have to know about the frequency. LRIT data frequency. Who will get the flag state, coastal state, port state, ship owner, surveyor, agent, and charters, piracy prevention task forces, SAR services. Now, what is the radar detection and ranging? So here, like it's the switch is provided to check the overall frequency of the set and the plumb sun patterns appears to screen while it on 1.5 range scale or other small range specified by the manufacturer. The length of the plumb radius of the sun pattern is measured with the gain set normal and both anti-clutter and differentiator control set at minimum. The present length of the plumb expressed as the percentage of maximum length in the formula, like the relative efficiency present length of the feather divided by maximum length in pass divided by into 100. If any accuracy drops by 80%, investing of a case must be cost. Okay, now this is all about here. Now switch on the radar. The procedure to check efficiency, perform the PM test, switch on the radar and we will go on 1.5 mid-range scale and the PL sector will form a short pulse position, clutter separation, differential control, minimum set gains, operator swing loaded performance monitor. Okay. Now we come to know about why radars can correct 6 any constraint imposed by the radar due to which early warning of risk of collision can't be avoided. Short range view, good resolution, evade detection, long range detail or gain. Okay, what are the limitations of radar pulse? Call pain to expand radially outward. It is the ability of radar to clearly distinguish two small vessels and as to separate. The factor it governs is pulse length, which cause all point to expand radially. Considering the two small targets that are in one bearing closest to each other, the paint of the nearer target would expand towards the other on the PPI by half PL in meters. If the distance between the two targets equal to or less than half PL, the paints would merge on PPI and show as if there were one target. If the targets are further apart, the half PL, they would paint as two separate targets on PPI. Horizontal discriminations. It is the ability of the radar setups to clearly distinguish two targets. Okay, beam targets. Cause the PPI to expand in azimuth by half as the path, the paints of two targets on same range slightly. Okay. Basically wavelength क्या होता है, that deionization. The pulse length, same waveguide and scanner used for transmission and for reception. उसमें शॉर्ट में आंसर है यार ये. Height of scanner, power of the set, the wavelength 3 centimeters due to 10 centimeters have a greater maximum range than 3 centimeters wave. The maximum range than 3. Okay, more the wavelength, more the range due to less attenuation and more refraction. Pulse length, so better maximum range. शॉर्ट में ये बीम विड्थ तो पूछते हैं यार, बीम विड्थ कहाँ है? The deionization delay, that is DR cell between the completion of transmission and commencement resistance. The delay increases the minimum detection. The VW and height of scanner above sea level affect the minimum range as these two factors govern the distance of which the lower edge of the radar beam will strike the sea ships. Okay. The VW and HBW, the narrower the beam width, the greater the direction. The narrower the beam width, the greater is the direction concentration of energy and hence the greater the maximum range accuracy of the of the radar depends on correct synchronization between the transmission of the pulse and commencement of the trace. Height of scanner and observing small targets very close by the radar measures the range from scanner to the target, whereas the correct range should be distance along the surface of the earth. Bearing accuracy of the radar depends on correct alignment between the heading marker and the scanner. Correct alignment between the heading marker and the bearing scale. Gyro, if any weather display is gyro stabilized. Type of bearing marker used. Rectilinearity of the trace, beam distortion, scale size of the spot. Speed over ground or speed through water, which must be used for collision avoidance. Obviously, speed through water. With respect to the bottom of the and speed through water. Now, true motion, relative motion is very easy. We have to just ये याद करना 75% से ज़्यादा हो जाएगा तो then it's automatically come to the same center point. The origin may be shifted at any time to any convenient part of the radar screen as desired by the observer within about 75%. Okay. The movement of all target on the radar screen as a true and relative motions is like stationary on other some collision avoidance is concerned. Relative motion is deemed suitable as it provide the movement of other. Okay. Now what is sea stabilization, ground stabilization? Sea stabilization, this pose no problem for collision avoidance as of navigation because the bearings and ranges for us are unaffected. Okay, the what is head up, course up and north up, this needs to be studied. And what is the IMO's performance? Okay, this is the requirement of an IMO. This I have to study, right? And what we say, the radar range scale and being accuracy depends should be range with 30 meter or 1% of the range scale in use, whichever is greater. Range within 30 meter or 1% of the range scale in use, whichever is greater. Within one, the gain control fluctuations. Range within 30 meter or 1% of the range scale in use, whichever is varying within one. The gain control function should be provided to set system gain or signal threshold level. A gain control function should be provided to set the system gain or signal threshold level. Effective manual and automatic anti-clutter function should be provided. There should be a clear and permanent indication of the status and level for the gain and all anti-clutter control functions. The X-band radar system should be capable of detecting the radar beacons in the relevant frequency band. The range and bearing discrimination should be measured in calm condition as range scale of 1.5 nautical mile or less and between 50% and 100% range scale detected. The radar system should be capable of displaying two targets in same bearing separated by 40 meters as two distinct of bearing to 2.5 degree as two distinct of the radar equipment should be fully run status within 4 minutes after switching on from cold. A standby condition should be provided in which there is no operation radar transmission. The radar should be fully operational within 5 seconds from the standby condition. Range scales of 0.25, 0.5, 0.75, 1.3, 3, 6, 12 and 200 should be provided. At least two variable range markers should be provided. A graphic line from the consistent common reference point to the bearing scale should be indicate the heading of the ship. At least two electronic bearing lines should be provided to measure the bearing of any object with the operational display area with the maximum system error of the 1% at the periphery of the display. The minimum of 4 independent parallel index lines with the mean to truncate and switch off the indicates line should be provided. A user cursor should be provided to enable a fast and concise means to designate any position on the operational display area. A true motion display should be provided. North up and course up orientation should be provided. Head up may provided with the display mode is equivalent to motion with a fixed origin. Manual of centering should be provided to locate the selected antenna position at any point within at least 50% of the radius from the center of the operational display area. Ground and sea stabilized mode should be provided. The tracking target facility should be available at least 3 to 6 and 12 nautical mile range scale. What is the PI in the radar? PI is very useful technique to allow watch deviation from the planned track and to constantly monitor whether the vessel is in right track or not. ठीक है, ज़्यादा क्या ही बोलेंगे इसमें. Position technical details of lights and shapes. Position forward mast light is 6 and 2 wells. Okay. On a power driven 20 meter mooring length, the mast light shall be placed as follows. There is only one mast light, should be at least 6 meter above the hull, and if 6 meters should be as high as possible. And it's okay. Then the masters are 4.5 and यार ये तो NX5 का वो वीडियो देखना पड़ेगा. Horizontal sectors and vertical sectors. Additional signal for fishing vessels. Additional signal for vessels 20 feet or more inland when engaged in trawling, whether you divorce or it's all about cards. Each vessel 21. Technical details of sound signals, frequency, range of portability. Now this is something good. Length of vessels in 200 or more. Octave band level in decibel required 143. Audibility range in nautical miles 2 miles 75 but less. The length of vessel 200 meter or more 2 miles 2 75 but less than 200 75 but less than 200 1.5 20 but less than 75. Okay, maximum is 2 meter only. Fitting of more than one whistles, bell or gong. If whistles are fitted on a distance apart or more than 100 meters, then they are not sound simultaneously. Having other sound signals that produce a pressure level of not less than. Vessels must be crafted from corrosions. The bell must be distress signals. This का काउंटर सेटिंग सॉरी कंटूर सेटिंग स्कैमिन AIO no that is hydrographic office this and this now we are discussing about the safety contour settings. That is generates alarm on ECDIS, a thick gray line, as minimum possible to safe versus unsafe water, and its safety contour plus squad plus environmental allowance shallow contour. It is almost equal to the vessel's draft deep contours gray area. So acknowledge ECDIS alarm should carefully. Being in gray mean that your vessel will be experiencing shallow waters effect. Action taken to avoid collision and be not delete a vessel's advance. Okay. So this is all about ECDIS in isolated danger marks. Camin Admiralty overlay. Admiralty may have been considered as an integral part of passage plan protecting an essential man going to the particular light long. Set one and advantage chart ABC is free of cost. AIO sent a vessel separate DVD should be downloaded into active and same way. And ENC permit to unlock the AIO should accompany the other permit cells. Admiralty AIO provides easy visibility to the mariner. The AIO layer, when turned on, provide pink polygons overlaying the ENC in area where TNP were effective. A list is issued by the Admiralty called Status of TNP information on ENC. This includes the countries issuing the ENC and whether TNP is being included ENC or not. Signed thoroughly will be seen on polygon. It must be plotted on ENC. What is the considered common reference point? The common reference point of the vessel is the coning station of the vessel. Steering control and device or ahead and astern propulsion operations are located. Where all equipments is considered, it is location on ships. Okay, ECDIS as 57 transfer digital. Describe the following information. Hydrograph ECDIS anti ahead grounds. Okay, so what is the depth is 14 when looked ahead. Setting give alarm ECDIS only alarm when setting over deep contour, shallow contour, and safety depth doesn't activate any alarm on ECDIS. What is the purpose of deep contour? ECDIS and safety alarm, so the acknowledging is carefully. कैटजॉक देख ले भाई पोजीशन एक्यूरेसी डेप्थ एक्यूरेसी how will you update chart on ECDIS? This will be remembered. First permit, next base, then finally we complete the user permit, the cell permit, the base, updating the ENC. Yeah, list the ECDIS performance standard. What is the difference between ENC and SENC? So what is the this performance standards of ECDIS? So this is the last which I'm reading, and this which is easy emergency procedures and all. Then we are done with then the miscellaneous questions. They won't ask, very rare chances to call masters and all. This is if in case required, then we'll be studying it. Otherwise, for now, we are just coming to an end. There it is. The ECDIS performance standard, the list of ECDIS performance standards. The effective size. List the ECDIS performance standard. Effective size of the chart presentation for route monitoring should be at least 270 by mm, 270 mm. ECDIS should facilitate simple and reliable ECDIS should facilitate simple and reliable updating of the electronic navigational chart. ECDIS should have at least the same reliability and ability of presentation of the paper chart published by government authorized. ECDIS should provide appropriate alarms or indication with respect to the information displayed or malfunctioned of the equipment. ECDIS should be capable of displaying all SENC information. It should easily add or remove information from ECDIS display. It should not be possible to remove information contained in the display base. It should be possible for the mariner to select a safety contour from the deep contour provided by the SENC. ECDIS should emphasize the safety contour over other contour on the display. ECDIS should provide a method to ensure that ENC and all updates to it have been correctly loaded into the SENC. It should not be possible to alter the content of the SENC. It should always be possible to display the SENC in a north-up orientation. Other orientations are permitted. It should be possible to adjust a planned route by, for example, adding waypoints to a route, deleting waypoints from a route, changing the possible of a waypoint, changing the order of the waypoints. It should be possible to enter the geographical coordinates of any positions and then display the positions on demand. It should store and be capable to reproduce certain minimum elements required to reconstruct the navigation and verify the official database used during periods 2 hours, 12 hours. The following data should be recorded at 1 minute intervals to ensure a record of one ship's fast track line, time, position, heading and speed. To ensure record of the official data used, ENC should addition itself and update the history. ECDIS should not degrade the performance of any equipment providing sensor input. It should be possible to operate ECDIS at all equipment necessary for its normal functioning when supplied by an emergency source of electrical power. What is the difference between this is one basic difference. What is the user permit, the cell permit and the base? Now what is this? Where it is? The user permit is the identity of the ECDIS. It is usually alphanumeric and must not be confused with cell permit. A single ECDIS will have two user permit, one for vector chart and one for raster chart. ARCS does not change and it's linked to a small dongle usually connected permanently to the ECDIS. Without a dongle, the ECDIS loses its identity and will not start. Each vessel can register up to 5 ECDIS with Admiralty. After the registering the ECDIS, vessel can now request for cell permits. A vessel cannot proceed with ordering permits or using ENC data from the VAR unless the ECDIS is registered. This is normally done at the time of installing the ECDIS on the vessels. The cell permits are basically key codes that unlock the ENC from the base DVD and allow it to Okay, so this is all about your ECDIS. So thank you, bye, tata.